All right, here we go. We are on chapter 8. Today's 8-1, geometric mean. The concept of today is incredibly easy, but there's a few things you have to remember. You have to remember how to simplify square roots and stuff like that. So I'm going to start with the way that it's written in your notes, but I'm going to show you another option too. I like to give you more than one option. So geometric mean of two positive numbers a and b is x, where a proportion a over x equals x over b. This is an option, okay? The one that I memorized when I was in high school was x equals the square root of a times b. So I'm going to show you that one and why I think that one's better, but I don't ever want you to feel like you have to do one over another. So either way, you have to memorize something, right? You either have to memorize this proportion or this equation. So here's why I think this one's better, okay? If we were to start with this one and cross multiply, I would get x squared equals a times b. Is everybody okay with that? This times this equals this times this. Square root both sides, and you end up getting what I started off with anyway. So I kind of saved a couple of steps by memorizing it that way. Does that make sense to you? So for today, I'm probably going to do them all using this formula. But if you want me to go back and show you proportions instead, if that's easier for you to understand, I'm happy to do that. But you'll have to do a couple of steps in between just to get caught up to here. So again, in my opinion, you had to memorize one anyway. You might as well memorize the one with less steps. That's just me. Okay? We have a couple theorems today. So theorem 8-1, if the altitude, so altitude is from the vertex to the opposite side, making a right angle. If the altitude is drawn to the hypotenuse of a right triangle, like this one is, CD, okay, then the two triangles formed, so this one and this one, are similar to the original triangle and each other. So what that means is, this triangle is similar to this triangle. This triangle is similar to the original one. This triangle is similar to the original one. That's what all this says, but in order. Does that make sense to you? So like angle A would be congruent, so you can't call it C, but angle C. Does that make sense? Okay. So they're similar to each other. This one's similar to the original big one. This one's similar to the original big one. Okay. Theorem 8-2, same concept. The altitude, again, AD here is the altitude, drawn to the hypotenuse of a right triangle. It was drawn to the hypotenuse of a right triangle. Separates the hypotenuse into two segments. The length of this altitude is the geometric mean between the lengths of the two segments. What that means is geometric mean is always something equals the square root of two things being multiplied together. It was, if you go back, don't write it here. I'm just trying to show you what it was. It was that thing. That's geometric mean. Okay. So the altitude here, it's called x, is equal to the geometric mean of the two pieces it created. X would be equal to the square root of y times z is the way that I do it. So I would write that in. The proportion is totally fine. It's correct. But I find that that's extra work, and I had to memorize this one anyway, so I went ahead and just did it that way. Again, if you don't like it, you're welcome to use the proportion. So altitude, x equals square root of this times this. Is that okay? 8-3. The altitude drawn to the hypotenuse of a right triangle, again, separates the hypotenuse into two segments. The length of a leg this time of this triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. That sounds intimidating. It's super easy. So this time we're talking about legs. So the legs of the original triangle would be what they had a W here and an X here. Those are the legs. Does that make sense? Okay. So I'm going to start with W. W would be equal to the square root of something times something. That's what geometric mean means. It's the square root of two things times each other. So this leg is equal to the square root of the piece adjacent to it, so the y, times the whole hypotenuse. That would be y plus z. I'm going to say it again. Okay. So the leg, W, is equal to the square root of this piece times all of it. So y times all of it would be y plus z. Do you guys see that? Yeah. Yes, we're going to do x next. Yep, we're going to do both. So another leg would be the x, right? What's the part adjacent to it? The z or the y? The z, right? So it's equal to the z times the whole thing. What's the whole hypotenuse? Z plus y, or y plus z, same thing. Is that kind of okay? I'm not saying you can do it yet, but you just follow what it says. Is that okay? All right. When you're ready, go ahead and turn to the back. We're going to do a couple. Find the geometric mean between each pair of numbers. So again, geometric mean is just a square root sign, multiply them together, essentially. Okay? Anyone still need that page? So I'm going to say x is equal to square root of 15 times 40. This whole chapter, you're going to have to remember how to simplify square roots. They're not going to want you to round typically. So 15 and 40 are not perfect squares the way they are, so I'm going to shove them together. What is 15 times 40? 600. Perfect squares, 4, 9, 16, 25, 36, 49, blah, blah. What? 25 works, but something higher works. Everybody forgets about 100. 100 is a perfect square, right? So 100 times what? 6. What is the square root of 100? 10. So 10 root 6 would be my answer. That's what they're looking for. Here's how I know I'm done. 6 is not a prime number, so I have to kind of check it. So the factors of 6 are 1 and 6. Are 1 or 6, well, 1's a perfect square, but it doesn't help me. Is 6 a perfect square? No, so that doesn't work. 2 and 3, are 2 or 3 perfect squares? No, so I know I'm done because 6 can't be broken down anymore. Is that okay? Anyone still need that one? All right, on the next one, don't let yourself be intimidated. Again, geometric mean is the square root of something times something. So I'm just going to say big square root sign, square root of 45 times square root of 80. And we're just going to leave it like that for a moment. That's the concept, square root of something times something. Okay? In any math class, typically you kind of start at the inside and work your way out. So I'm going to go ahead and I'm going to ignore this square root sign for a moment, is what I'm saying, the big one, okay? I'm going to take these two and shove them together, just like we just did. So take 45 times 80. So that's the square root of 3,600. Again, I'm ignoring the big square root sign. I'm going to write it down so I don't forget it, but I'm kind of pretending it's not there for a second. What's the square root of 3,600? 60. So the square root of 3,600 turned into just a 60. But that original square root is still there. Do you guys get that? Okay. 60 is not a perfect square. You can try if you want to, but it's not. So we have to break it down and find a perfect square that goes inside of it. 4, 9, 16, 25. What goes into 60 evenly? The highest perfect square that goes into 60 evenly. I always start with 4. 4? 4 and what? 15? So 4 is the perfect square. It's 2. 15 is not. If I check it though, 15, I've got a 1 and a 15. Well, that didn't help me. I've got a 3 and a 5. That didn't help me. So my final answer is 2 root 15. Is that okay? Yes. 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 Typically, you start on the inside and work your way out. Yeah. I don't know how you could do it otherwise. If this had been a perfect square twice, if it had been the 3,600 and that had been a perfect square, you could have put the whole thing in your calculator. But because the 60 wasn't a perfect square, your calculator really wasn't going to help you until the end. Does that make sense? Yes, that would be fine. But if you would put this square root sign in, it would not give you that. Most calculators don't give you that. There's a few that do, but even the $100 ones don't do that. Okay? So her question was just reiterating that we started here and worked our way out. Okay? All right, let's see. Find x, y, and z. This is your geometric mean again. So you're going to take the altitude, so y, okay, is equal to the square root of these two times each other. 4 times 6. Is that okay? Does everybody understand that part? Everything else is just math. It's the setup that's kind of tricky. So you can shove those together if you want to. That's fine. But 4 is already a perfect square. So I'm going to go ahead and just break it down the way it is. That's going to be 2 root 6. Do you guys see what I'm saying? 6 can't be broken down. Okay. You could have shoved it together and made it square root of 24, but you're going to have to pull out the 4 anyway, so it was kind of already ready to go. Does that make sense to you guys? Okay, so 2 root 6 is for the y. If I'm trying to find the x, that's a leg, right? It's going to be something times something, geometric mean, under a square root sign. So my leg x is equal to the adjacent piece, so that's your 4, okay, because it's adjacent, times the entire thing. The 4 plus 6 would be my hypotenuse. So obviously we all know that's 10. Because it's your notes, I'm leaving it as 4 plus 6 first. That way you can remember where we got the 10 from. You don't have to do that. I just find that to be helpful when you come back later. So I'm going to go ahead and simplify that. That's obviously 4 times 10. You could, again, shove them together if you want to. But 4 is already a perfect square where it is. So I'm going to say 2 square root of 10. And then I'll be like, okay, can I break down the 10? So you have a 1 and a 10, not helpful. 2 and a 5, not perfect squares, so no. Is that okay? If you had made it the square root of 40, you just would have gotten yourself back here again. Either way, it's not like it's wrong, it's just a little extra. Okay? Why don't you guys try to set up the geometric mean for z? It's going to be something times something. Don't do the math yet, just set up what you think it should be. So what is adjacent to the leg z, the 6 or the 4? The 6, and what's the whole thing? The 10, right? You could go ahead and write 10 now. So z is equal to the square root of the 6 times all of it, the 10. Neither of those are perfect squares, so I have to shove them together. It's not an option. 6 and 10 by themselves don't help me. So 60, what's the highest perfect square that goes into 60 evenly? 4 and 15. Square root of 4 is 2. Square root of 15. Those are my 3 answers. Are you guys okay? Did I lose anybody? All right. Same concept. With this one, I typically start with the altitude every time. I don't know, that's what I do. So I'm going to start with the x. It's square root of something times something. So the x would be equal to the square root of the y times whatever this is. I don't really know, right? So it's equal to y times other way around. 14 minus y. If all of it's 14 and this much is y, then this has to be 14 minus y. Does everybody understand that? Okay. Yep. The two pieces together. And then the legs are the adjacent piece times the whole hypotenuse. Okay. So obviously I can't solve that. I can't solve with 2 variables. So I'm going to have to go and find y and then come back, right? So I'm going to go ahead and find y. So let's do the 5. So this leg is 5. It's equal to the adjacent piece, so the y, times all of it, the 14. I'll say it again. The leg 5 is equal to the adjacent piece, the y, times the whole hypotenuse, the 14. Is that okay? So that square root's annoying. It's in my way. How do I make it go away? Square both sides, right? You square root, they cancel out. So 25, I'm going to say equals 14y this time. Because y14 is kind of weird. How do I get y alone? Don't be fancy. Divide by 14. So I get 25 over 14. That's fine. You can leave it that way. It doesn't reduce. It has to be leg equals adjacent hypotenuse. That's the formula. So no, you couldn't start with the y here because it's not a leg of the original right triangle. Does that make sense? Okay. So I'm going to go back over here and replace all the y's with 25 over 14. Did I lose you? Yes. Yep, because I just divided by the 14. So it wasn't a pretty decimal, if I remember right. You could change it to a mixed fraction if you want, but to me, 25 over 14 is fine. It doesn't reduce. So if that had been 26 over 14, divide by 2 or whatever. Okay. So all these y's, I'm going to replace with 25 over 14. You can do this without a calculator. It's just not super fun. So go ahead and get out your calculator. don't take the square root until the very, very end. I would go ahead and take 25 over 14 times the 14 minus 25 over 14. It's not that hard of math because the 14s cancel here for sure, but you have a calculator, so let's use it. What'd you get? It's not pretty. Super big. 21 and 159 over 196. Yeah? 21 and 159 over 196. Everybody take your time and get that. Obviously, you could take the square root of that if you want, but it's not a perfect square, so we're going to have to leave it that way. You could have made it improper if you wanted to, but most of your calculators don't go over 3 digits for the numerator of a fraction. So I'm pretty sure this is the only way you can do it. Everybody take your time and make sure you get that. You guys okay? Like 4/9 would be 2/3. Is that what you mean? Sometimes, if I had, I think of one. I would want like a fourth, but let's do like, make one up and then I'll do it that way. Like 9 over 4 would be, what is that? You said you wanted a mixed fraction, right? Was 9 over 4 is a mixed fraction? 2 and a fourth, right? Because there's 8, 9. So you would have had it this way, and then I would have been like, oh, just kidding, that's 9 over 4, and then that's 3 over 2. Improper. Yeah, if it's a mixed number, if it's a mixed fraction like this, if you're, well, your calculator would have done this for you. If it's a perfect square, you can take 2 and a fourth in your calculator with the square root sign. It would give you 1.5, but you would know that that's 3 halves. Either way, it would be the same. So you can keep it this way and use your square root button, and it's not going to give you a perfect square. It's going to give you a super long decimal. So that would have been your hint that there's no reason to change it. Does that make sense? Okay. All right, letter Z. This is a leg again. So Z is equal to the piece attached to it, the 14 minus Y, times the whole thing, 14. So it's equal to the piece attached to it or adjacent to it, 14 minus Y, times the whole thing, the 14. Obviously, you can put the 14 in front if you want to. Some people prefer it that way, but it doesn't matter. I'm going to go ahead and replace the Y with the 25 over 14 from before. So Z equals, I'm going to put the 14 in front. Most people like it better that way. So 14 minus 25 over 14. Again, it's doable without a calculator, but most people probably should just use a calculator. And that's fine. So find Z. What do you get? Square root of what? 171. So pretty okay there? And then we have to simplify it if possible. So 4, 9, 16, 25. What goes into 171 evenly? 9, 9 and 19. 9's a perfect square. What is the square root of 9? 3 root 19. 19 is a prime number, so you know you're done. Questions anywhere? The only reason that one was, in my opinion, tricky was just because they made it super not pretty numbers. But it's geometry now, so it's okay if they don't always work out nicely. Don't think you're wrong. Okay? On this last question, number 35, I want you just to set it up. I don't want you to solve anything. I just want you to do step 1. And let's see if you can do it without me. We have an altitude, so it's going to be theorem, I think, 8.2. You're struggling on how to set that up? So altitude equals geometric mean of the numbers that it created, I guess you could say, the pieces that it made. So what is the altitude here? 12. equal to the geometric mean, so something times something under a square root sign, of the two pieces that it made. So the 24 and the t plus 1. That's how you set it up. Is that okay? The square root's annoying and it's in my way. How do I make it go away? Square both sides, because what you do to one side, you have to do the other. They cancel out each other out. So 12 squared is 144. And it's equal to 24 still t plus 1. Now what? Distribute, right? So 24t plus 24. And then subtract the 24. So what's 144 minus 24? 120 equals 24t. Divide by 24. T is 5. Did I lose anybody anywhere? Okay. This is definitely an assignment where I'd keep my notes out. It's not a hard thing to do, but I know that it gets confusing about what to put where. So I would keep my notes out to help you kind of with the assignment. So obviously this is not due tomorrow, but tomorrow's question day. So since you have so much time, I might be looking at it tomorrow. So make sure you guys are being productive and see me if I lost you somewhere, okay?